In today's discussion, we are going to tackle about the introduction to integration. And today's lessons, our focus is the basic rules of indefinite integral. So, let's start this discussion. Let's start to the constant. So, let's say we have this. We have the integral of 2 dx. The 2 here is the constant. So what we do is just simply set it on the left side of the integration symbol. So we have this one, 2, and the integral of dx. So the integral of dx is x. So what we have now is 2, and the integral of dx is x, so we have 2x. And since it is indefinite integral, so it is indefinite integral, don't forget to write plus c, or plus the constant. So that's our first rule. It is the integral of constant. So let's try another example. Let's say we have the integral of pi dx. Our constant here is the pi. So what we need to do is to put it on the left side. So what we have now is pi times the integral of dx. The integral of dx is x. So what we have is pi times x plus c. Let's try another example. Let's say we have the integral of e dx. Our e here is constant. So what we need to do is to put it on the left side. So what we have is e times the integral of dx. So the integral of dx is x. So what we have is e times x plus c. So that's the first rule. Now, let's have this general equation. Let's say we have this. We have the integral of x raised to n dx. So the integral of x raised to n dx is equal to this. X raised to n plus 1 over n plus 1 plus c. So that's the general equation. To understand it further, let's have an example. For example, let's have the integral of x squared dx. In this example, the value of n is 2. So what we have is x raised to 2 plus 1, which is equal to 3, over 2 plus 1, which is 3, then plus c. So that's our answer. Let's have another example. Let's say we have x raised to 5 dx. So in this example, our n is 5. So the integration, or our answer here, is x, then 5 plus 1 is 6, over 5 plus 1 is 6, plus c. So this is our answer. Now, what if we combine constant and the variable? Let's say, for example, we have this. The integral of 5x cubed dx. Like what we did earlier, what we need to do first is to put on the left side the constant. So what we do is this. 5 times the integral of x cubed dx. Now, The value of our n here is 3. So what happened is we have this one. 5 times x. So our n here is 3. So 3 plus 1 is 4 over 4 plus c. So this is our answer. Let's try another example. Let's say we have this. We have 15 x squared dx. What we need to do is to put the constant on the left side. So 15 times the integral of x squared dx. So our n here is 2. So what we have is 15 times the integral of x squared dx is x. 2 plus 1 is 3 over 3 plus c. Since we can simplify it, so what we have now is this. 5x cubed plus c. So this is our final answer. Now, let's try it in polynomials. So let's have the integral of polynomial. So for example, we have this one. The integral of x cubed plus 3x minus 3 dx. The first thing we need to do is to distribute the integration symbol. So what we have is this. The integral of x cubed dx plus, so let's put at the left side of the integral symbol the constant. So 3, then x dx minus 3 dx. Then we can do the general rule for this indefinite integral. So our n here is 3. So what we have now is 3 plus 1 is 4 over 4 plus 3 times our n here is 1. So we have now 1 plus 1 which is 2. So we have x squared over 2 minus 3 times the integral of dx is x. Then don't forget the plus c. So this is our answer now. If it is no longer simplifiable, so this is our final answer. Now, let's try the integral of radical sign. Let's say we have this example. The integral of square root of x dx. If we encounter this type of integration, what we need to do first is to use the law of exponents in terms of radical sign. So what we need to do is to simply convert this radical sign into exponential form. So in this form, square root of x is also written in this form. X raised to 1/2. Then copy dx. Therefore, our n here is 1/2. So 1/2 plus 1 is equal to 3/2. So what we have is x raised to 3 over 2 over 3 over 2 plus c. And remember, we can simplify it further since it is in the form of all over. So what we need to do is to get the reciprocal of 3 over 2 and multiply it to x 3 raised to 2. So what we need to do is just simply copy x raised to 3 over 2 over 1 times the reciprocal of 3 halves, which is 2 over 3. Then it is equal now to 2x raised to 3 halves over 3 plus c. And we can also transform this exponential function into radical sign. So what we have is 2 raised to or multiply to square root of x cubed over 3 plus c. So this is our final answer. Let's try more of a radical sign. Let's say we have this. The integral of cube root of x squared dx. The first thing that we need to do is just simply convert this radical sign into exponential function or in exponential form. So what we have now is this x raised to 2/3 dx. So our n here is 2/3. So 2/3 plus 1 is equal to 5/3. So what we have is x raised to 5/3 over 5 over 3 plus c. So we can simplify it. What we have is x raised to 5 over 3 over 1 times the reciprocal of 5/3, which is 3/5. So we can solve for this. We have this one, 3 x raised to 5/3 over 5 plus c. And we can convert this exponential form into radical form. So what we do is just simply 3 times the cube root of x raised to 5 over 5 plus c. Always remember that the numerator is the raised inside the root and the denominator is the root in terms of the exponential to radical form, in terms of conversion of that. So you can watch videos in terms of conversion the exponential form into radical form. Now let's try another rule of integral form wherein it involves product of a binomial. So let's say we have this example. We have the integral of 3x plus 1 squared dx. The first thing that we need to do is to expand this binomial so that we have this one, the integral of 3x plus 1, then 3x plus 1 dx. Then let's solve for this. So 3x times 3x is equal to 9x squared. Then 3x times 1 is equal to 3x. Then 1 times 3x is equal to 3x. Then 1 times 1 is equal to 1. Then copy dx. The next thing that we need to do is to combine like terms. So we have 9x squared plus 6x plus 1. What you notice after solving this product of a binomial we end up into a polynomial so that we can solve it like what we did earlier. So first, distribute the integration symbol. So we can have this x squared dx plus 6, then x dx plus 1 dx. So our n here is 2. So what we need to do is just simply 9. Then 2 plus 1 is 3. So 3 over 3 plus our n here is 1. So what we have now is 1 plus 1 is equal to 2. So x squared over 2 plus the integral of dx is x. So plus x. And don't forget the plus c. And we can simplify it so that we have this one. We have 3x cubed plus we can simplify it also. So what we have is 3x squared plus x plus c. So this is our answer. Now, let's have the integral of a fraction. Let's say, for example, we have this one. The integral of 1 over x squared dx. Based on our previous discussion, we can transform this fraction into this one. We have x raised to negative 2 dx. Therefore, after converting this fraction into this form, we now have the value of n, which is negative 2. So, what we have is negative 2 plus 1 is equal to negative 1. So, what we have is x raised to negative 1 over negative 1 plus c. So, what we need to do, since we have this answer, we can simplify it further. So, we can bring down x to the denominator to have a positive exponent. So, what we have is this one. We have negative. So, let's have 1 and bring down variable x into denominator so that we can have a positive exponent. So, this is the value. Then, plus c. So, this is our final answer. Now, let's have the integral of a logarithmic function. But before that, let me introduce this interesting example. So, what is the integral of 1 over x? So, what is the integral of 1 over x dx? So, if we use the integral of fraction, what we have is this. So, if we transform 1 over x, what we have is this. X raised to negative 1 dx. So, what happened here? Our value of n is negative 1. So, negative 1 plus 1 is 0. So, what we have is x raised to 0 over 0 plus c, which is undefined, right? Therefore, I wanted to introduce to you the idea of the general expression of logarithmic function or the integral of logarithmic function. So, this is the general equation for that. The integral of 1 over u du is equal to ln u plus c. So that's the general expression. Therefore, the integral of 1 over x dx is simply ln of x plus c. Let's try another example. What if we have 1 over x plus 3 dx? So, the value of u here is x plus 3. So, what we have is ln of x plus 3 plus c. So, that is our final answer. Let's try another example. What if we have this one? We have 3 over x minus 2 dx. The first thing that we need to do or understand, the 3 in the numerator is a constant. So what we need to do is just simply put it on the left side. So what we have is 3 times the integral of 1 over x minus 2 dx. Then, our u here is x minus 2. So what we have is 3 times the ln of x minus 2 plus c. So that is our final answer. Now, let's proceed to another integration, which is involving exponential function. I wanted to show the general expression for the integration of exponential function. Let's say the integral of e. So let's redraw our integration symbol. So let's say we have the integral of e raised to u du. So the integral of e raised to u du is simply e raised to u over the derivative of u plus c. To understand this general rule, let's have this example. Let's say we have the integral of e raised to 5x dx. Our u here is 5x. So what we have is e raised to 5x and the derivative of 5x is 5. Then plus c. So that is the answer. Let's try another example. What if we have 7e raised to 2x dx? The first thing that we need to understand is the 7 here is constant. So let's put it on the left side. So what we have is 7 times the integral of e raised to 2x dx. So we can now proceed to the integration of exponential function. So it is equal to 7 times, our u here is 2x. So what we have is e raised to 2x. Then the derivative of 2x is 2 plus c. If your answer is no longer simplifiable, this is the final answer. Now, let's try all about the integration of trigonometric function. The first one is the integral of cosine u du. So the general rule here is that the integral of cosine u du is equal to sine u over the derivative of u plus c. So let's have this example. Let's say we have the integral of cosine x dx. So our answer is, our u here is x, so we have sine x and the derivative of x is 1, so over 1 plus c. So that is the answer. Let's say we have another example. What if we have cosine 2x dx? The value of u here is 2x. So what we have is sine 2x over the derivative of 2x is 2 plus c. So that is our final answer. Let's have another example. What if we have the integral of 3 cosine 5x dx? The value of 3 here is constant, so we can put it on the left side. So we have this 1 cosine 5x dx. Our u here is 5x, so what we have now is 3 times sine 5x over the derivative of 5x, which is 5, then plus c. This is the final answer. Now, more of trigonometric function, but by this time the general rule for the integral of sine u du. So we have the integral of sine u du is equal to negative cosine u over the derivative of u plus c. So let's have this example to understand this general rule. Let's say we have the integral of sine x dx, which is equal to, our u here is x, so what we have is negative cosine x, and the derivative of x is 1, so over 1 plus c. So that is our answer. Let's have another example. Let's say we have the integral of 5 sine 3x dx. 5 here is constant, so we can put it on the left side. So what we have now is sine 3x dx. The value of u here is 3x. So what we have now is this 5 times negative cosine 3x, and the derivative of 3x is 3 plus c. So this is our final answer. Now let's try the third general rule for the integral of trigonometric function. The third general rule states that the integral of secant squared u du is equal to tan u over the derivative of u plus c. So let's try it. Let's say we have the integral of secant squared x dx. So our u here is x. Therefore, we have tan x. And the derivative of x is 1. So over 1 plus c. So this is our answer. Let's try another example. Let's say we have 5 secant squared 3x dx. The value of 5 here is constant, so we can put it on the left side. Then what we have now is secant squared 3x then dx. The value of u here is 3x. So what we have now is 5 times tan 3x. And the derivative of 3x is 3. So over 3 plus c. So this is our final answer. Let's try the fourth trigonometric function, or the fourth integration of the trigonometric function, fourth general rule rather. So it states that the integral of cosecant squared u du is equal to negative cotangent u over the derivative of u plus c. So let's try an example. Let's say we have the integral of cosecant squared x dx. So our u here is x, so what we have is negative cotangent x, and the derivative of x is 1, so over 1 plus c. So that is our final answer. Let's try another example. Let's say we have the integral of cosecant squared 3x dx. So the value of u here is 3x. So what we have is negative cotangent 3x. And the derivative of 3x is 3 plus c. So this is our answer. Now, let's go to the fifth general rule for the integration of trigonometric function. And it states that the integral of secant u tan u du is equal to secant u over the derivative of u plus c. So let's try an example. Let's say we have secant x tan x dx. Our u here is x, so what we have is secant x, and the derivative of x is 1, so over 1 plus c. So this is our answer. Now, let's try another example. Let's say we have the integral of 5 secant 2x tan 2x dx. First thing that we need to do is to set aside or put on the left side the value of constant 5 times the integral of secant 2x tan 2x dx. Therefore, we have 5 times the value of u here is 2x. Therefore, we have now secant 2x, and the derivative of 2x is 2 plus c. So, this is our final answer. Now, let's go to the final general rule for the integration of a trigonometric function. Now, it is all about the integration or the integral of cosecant u times cotangent u du. So, the integral of that is negative cosecant u over the derivative of u plus c. So, let's have an example. For example, we have cosecant x times cotangent x dx. So, the value of u here is x. So, what we have is negative cosecant x. And the derivative of x is 1. So, over 1 plus c. So, this is our answer. Now, let's try another example. Let's say we have the integral of 6 cosecant, let's say 3x, then cotangent 3x and dx. The first thing we need to do is to put on the left side the constant. So 6 times the integral of cosecant 3x cotangent 3x, so dx. So what we have, the value of u here is 3x. So what we have is 6 times negative cosecant 3x, and the derivative of 3x is 3. So we can simplify it further, 6 and 3. So what we have now is negative 2 cosecant 3x plus c. So this is our final answer. So that's the end of the discussion of the introduction to indefinite integration. That's all. Thank you.